All right, welcome to Mathematics. Anyone? Today I will teach you this topic, derivatives of inverse trigonometric function. This is our topic. I will divide my class in two different topics. First one is inverse of function rule. I'm going to show you what is the inverse function rule. The second part of my class today, I will show you how to find derivatives of inverse trigonometric function. All right. So the first problem that we have here is the function f has the inverse function. This f to -1. This inverse function. If f of negative a is equals 4 and f prime, the derivative of negative a is equals -3, what is f? What is f to the -1? The inverse, the derivative of 4. Okay. I will remember you some ideas in this case. So a function g, for instance, a function g, okay, has an inverse function and has an inverse function. Okay, each output, this has an inverse function. Okay, each output value of g comes from exactly one input value. All right. So the inverse function of g here in this case, we have to remember these ideas. The inverse function of g is for instance, the inverse function of g is written in this way: g minus 1. So this is the way, as we have to remember this. Okay, the function g to the -1 takes each input value of g, all right, to the corresponding input value, okay. So one way to simplify this idea, this concept, for instance, if we have g to the -1 of, for instance, b, so this is will be equals a if, all right, if and only if, so that's a rule, g of a equals b. So this is the concept that we have to remember. All right, so if, for instance, if g of a, right, equals b, and g prime of g as a difference of 0, of course, this is the derivative, the derivative, the derivative. So the derivative of g to the negative, the inverse, evaluated at b is, so I will to write the formula. So this look at the concept we will have here. Maybe let's write it here, the formula g to the -1. All right, this prime, you write a little comma on top of 4. Not right now the variables. This is a problem. Just write it right here. B. This will be equals. See, look at this. 1 over g prime times here g primes minus 1 times b here times b. That's the main formula. This concept is very, very important to remember, to understand the rule. This is the rule how we are going to find the answer in our problem. Okay? See? So let's go and then let me find the answer to our problem. Just applying the inverse function is how work the inverse function here. Okay? Let's write then a problem here. All right. We have this data. So rewrite. We have to rewrite f to the -1 here prime of 4, right? So using the formula for the derivative, remember the formula I give it to you for the derivative formula, at the inverse function, we have to write it then this question here. So f -1 here let's write it come here right here 4 equals, remember the formula, just write one and on top, and then f right here prime times f to the -1 power times 4. Okay, right here we have it. The denominator here is a composition of function. This is a composition of function, right? To find it, work inside out. We have to work inside out. So start with a f. Start with we have to f -1 here, and this equals 4 or 4. This is 1 or 4 right there. Since we have, look at this, since we have f of a -8 of a negative equals 4 here, equals 4. Look at the data. Don't know that, and then f to the -1 here of 4 equals -8, right? -8 right here, -8. See, you are here, substitute into this formula. We have to substitute into this formula, right? We have here, so I will to write it again, f to the -1 times 4 right here equals 1 divided by just write the formula times f -1 times right here 4 close, then equals right here will be equals 1 here, and the bottom we have to write f times a -8, f to the f right here. See, look at this. So you know that f1, for instance, if of -8, you know that is equals -3, right? So complete the calculation, we have to write continue here. Let's see, right here. So we will write f to the -1 right here. So here I will to write -1 here, -1 right here. All right, times 4 will be equals 1 f prime times -8 right here. So right here is 8. So equals is going to be equals right here 1/3. 1/3, right? 1/3. So the answer here in our problem, so our conclusion, f to the -1 this is the derivative, mean the derivative of 4 is equals 1/3. That's our answer. That's our answer. The solution for our problem that we have it right here. Okay, just apply or substitute the formula. That's it. It's no confused. All right. So I will continue with the second one. This was the inverse function rule. Just apply the formula. I already give you the formula, right? Just substitute the numbers. That's it. It's nothing difficult. It's very simple. Now let me find number 2. That's the section of number 2 of the class. To find, we have to find in this section derivative of inverse trigonometric function. Trigonometric function. All right. Our problem is find. Let's write the problem. It's only one problem. Find the derivative this is very simple of f of x. All right. So if the derivative of x equals, we have to find the derivative of this. So we have to remember here. I will to solve in this size our problem. Here, we have to remember this. Very important. Remember, this is a clue for our class today. We have we are gonna divide my square in some section right here. And that's very important. This is a clue for our class today. Let's write here u x and then on top and then this side u x. Okay. So here this is a table. We have arcsin x of x, and then we have, and this is will be equals 1. This is a mandatory rule. There is a formula divided by a square over 1 minus x to the second power. And next we will have arc cosine of x, and this we will write here minus or negative 1 divided by square root. So this is negative 1 minus square root minus x to the second power. The next one, arc tan of x. So here we have to write 1 divided by x to the second power plus 1. Okay, that's this is the clue for our class. So we have our problem right here. So we are talking about that. This table, the function arctan is equals sometimes, for instance, sometimes it's writing like tan minus 1. This function, the last one over x. Sometimes it's writing like that. Okay, so we have to remember, use the formula, these formulas for the derivative arctan. And this arctan, we have to use the formula for the derivative arctan. Okay, so we have this problem is if we have to find the, let's write make a picture of the problem here. So the derivative of x, our problem is going to be f of x equals let's write arctan of arctan of x. This is the problem that we have to solve. So we have to find the derivative of x right here. Okay, now it's right. This is our problem. So we have to take a look from which formula we have to take. Arctan, we have to take this formula, this one. Okay, to do this, just write it if right here, if because we are looking for the derivative. All right, equals, we have to write right here arctan. Okay, arctan or x right here in this way. See, so this is equals, easy. What is the answer? It's right here. So this is equals 1 divided by x to the second power plus 1. All right, that's the solution. Let's write another problem for. Let me do another one. Let's just be, it's very simple. This find the derivative of x. Let's write f of x equals a sign arctan of x. Again, if derivative, okay, use here we have to use the formula. So use the formula. We have to use the formula. This one, f of x equals arctan, yeah, arctan of x, like this. So it's this one. So 1 divided by x to the second power plus 1. Whatever, you have some problem like, for instance, arcsin of x or arccos of x, just write this formula. That's the answer. So this is very simple. It is not hard, not complex. Here is not, no difficult. All right, that's it for today. I hope this class be helpful for your class and calculus, right? So thank you so much. I'm waiting for you here in Nani and Matematicas. Anyone next time. Thank you so much. See you next time.